Okay, so the next topic is one of my favorites as an experimentalist, because we're going to talk about how you measure strain. So we're going to say that this is measuring strain up here at the top. And I want to talk about an experiment here. So we have our rod here, and we're going to subject it to a uniaxial force. And what we really want to know is, well, what's the strain right there at that point with the blue X? Well, what would you do? You could go in with your ruler and maybe you get really close and you think about how you could possibly measure the change in length over the length. So at the end of the day, what is important to recognize is that strain measurement at a single point is not possible. There's always going to be some gauge length that we need to measure over, some initial length, right? And so typically what we'll do is we'll take 2 points along our rod and we'll measure the length between them. So we would have some length initial, and once we stretch the rod, we would have some new length, and we could measure that, and we could figure out what the strain is over that gauge length, which would be this guy here. This is our gauge length. All right. Now, to think about how we might do that, let's say that we have a strain of 0.002. Okay, and that's going to be right about where steel yields. And let's say that our gauge length is going to be equal to 10 inches. And what would the displacement be that we would measure from that? Well, if our gauge length is 10 inches and we have a strain of 0.002, then we should get a displacement of 2/100ths of an inch, which is about 1/2 millimeter. So if you had nothing but a ruler, this would be pretty hard to measure with a ruler. But if you had a pair of calipers, yeah, you could probably measure that. Instead, we tend to use other techniques to do that. Some of them electronic, some of them have to do with optical systems, some of them fiber optics, but let's talk about kind of a number of them. So we measure average strain. Over some gauge length, and it depends on the system and it depends on how small that gauge length is, but you can get any more. You can get really nice and interesting strain pictures of materials. But there's some different ways, and so I want to talk about what those different ways would be. So one I'm going to say is an extensometer. So that would be a lot like our pair of calipers. It's just it's a way to measure displacements using a device that is electronic, and so it has a gauge length and it tells you what the change in length is for a given displacement, and then you can figure out your strain from that. There's some kind of more interesting ones. One of those is a vibrating wire gauge. And a demonstration of that is I'm going to use this rubber band. So if you ever tuned a guitar, you know exactly how this works. So if my rubber band is stretched this much and I pluck it, you get one sound. If I stretch my rubber band and then pluck it, I get a higher pitch sound. And so what I can do is attach my rubber band, and typically a wire, to my piece of material, and then as it strains, it's going to change the pitch of my wire. And if I have the electronic components, I can pick that change up, and I can relate that to the change in length. I can also use lasers. So lasers, if you have a laser extensometer, you can track points using that laser system very accurately. You can also just use cameras. So there's several different optical tracking systems. Some of the things that are a little bit newer here. So we also have another optical system called digital image correlation. And that is where you have a camera, and it's tracking kind of a speckle pattern on the material, and it can digitally track all of those different pixels, and that can give you some really rich strain information. You can also use fiber optic cables. So there's you can either use fiber Bragg gratings, which is it changes the resonant wavelength of a little piece of the fiber optic cable. You can do things with scattering principles, things like that. And probably the most simple and one of the oldest ways to measure strain is going to be electrical resistance strain gauges. And that is going to be what we talk about in our next video. So we'll talk a little bit about how they work, and then we'll talk about some transformation equations you can use to get an idea of what the average strain field looks like in a location.